Today is 6th of November 2020, and in last class we have discussed the advanced and critical welding processes. In brief, we have discussed laser beam welding, plasma arc welding and laser beam welding. Now today we will start with some topics we have missed yesterday in previous class, that is the advantages, limitations, applications of plasma arc welding. So we will start with advantages of plasma arc welding, in short PAW. So first advantage, that is it permits faster metal deposition, and high arc travel speed. As compared with TIG. TIG is always written in capital. Uniform penetration is possible. This is the second point. Number 3, the stability of arc can be achieved. Number 4, we get excellent weld quality. Number 5, it can produce radiographic quality weld. At high speed. So 4 and 5 basically similar. Number 6, it can weld steel pieces up to about ½ inch thick square butt joint. Now we will discuss about the limitations of plasma arc welding. The limitations, in the first point we will say that special protection is required as generation of infrared and ultraviolet radiations get produced. This is a very important point. It can harm our skin, it can harm our eyes, maybe skin cancer may also occur for a long time exposure. Second problem is consumption of inert gas is very high. then as there is very high voltage to be, high current also to be engaged, so more chance of electrical hazards are associated with this process. Number 4, ear plug is necessary because of unpleasant disturbing and ear damaging noise. Now we'll discuss the applications. It can weld titanium up to 8 mm thick. So welding titanium is a very difficult job. So for that this plasma arc welding is used. Nickel and high nickel alloys are welded, because if you add nickel, the nickel has very high melting point. For melting other high melting point metals. Number 4, carbon steel, stainless steel, nickel, copper, brass, monel metal, inconel, aluminium, titanium. These all can be welded. And welding of rocket motor, basically the casing, is done. So these are the several points, and there are few more applications as the effect of plasma arc welding compared with TIG welding, that is also available and important, but I will not discuss here. I will discuss in a very brief way. In plasma arc welding, there are two type of inert gases required. One is plasma gas, second one is shielding gas. In TIG welding, only one type of gas, the only shielding gas is required. Now in plasma arc welding, there is a option of constricted arc where the workpiece is not a part of the circuit, but in TIG it is a non-constricted arc and workpiece is a part of the circuit. In plasma arc welding, the electrodes remains within the nozzle, but in TIG welding, the electrode does not remain within the nozzle. It is provided externally. In plasma arc welding, very high temperature, that means about 11,000 degrees centigrade, can be achieved. but in normal TIG welding, only 4000 degree centigrade can be achieved. In plasma arc welding, because of the high temperature produced, deeper penetration can be achieved than TIG welding. The input heat distribution of the job are improved in plasma arc welding, but in TIG welding, the input heat distribution is not so improved. In plasma arc welding, only the filler rod coming within the electrode is sufficient, but in TIG, more filler material is required. In plasma arc welding, the metal debauching rate is faster than the TIG. And in plasma arc welding, the inert gas consumption is very high. In TIG, inert gas consumption is not so much high. The equipment in plasma arc welding is costly, and in TIG welding, it is less costly. And with plasma arc welding, because of the high temperature produced and high velocity of the gases, the cutting of hard and brittle material is possible. But with TIG, cutting of hard and brittle material is not possible. Okay, so these are very easy point. You just use your brains. You use to remember these two characteristics of these two different type of welding, and you will be able to compare between plasma arc welding and TIG welding. Now we'll advance to our next topic, which is ultrasonic welding. In ultrasonic welding, what we require is a high frequency converter. First, we write out the equipments. First, we require a high frequency converter. The job of this high frequency converter is we receive the 50 hertz current as input, and we convert it with a very high frequency like 20,000 hertz to 60,000 hertz. Ultrasonic means it is beyond humans hearing capacity. So human can hear from 20 hertz to 20,000 hertz. So more than 20,000 hertz means it is beyond our human hearing capacity. So from 50 hertz to more than 20,000 hertz, this is a very very high. So that's why a high frequency converter is required. Second, a transducer coupling system. An anvil, a force application device, a timer, and a control system for electrical, electronic, hydraulic, or pneumatic system. So now what happens here, there are the high frequency converter which is used for producing high frequency critical power at design frequency for the welding system or purpose. So there is a control system which converts the frequency from 50 Hz to our desired level. might be 20,000 hertz, might be 60,000 hertz. So the range is from 20,000 hertz to 60,000 hertz. Is very high. Now, this transducer coupling system consists a transducer that convert the electrical power into elastic vibratory motor, and a coupling system include the sonotrode tip which conduct vibratory power to the weld zone. Okay, so transducer, we know it converts the electrical energy into mechanical type of energy in terms of vibration here, and the product we use here, the component we use here to transfer the vibration towards the workpiece from this transducer is called sonotrode. So now I am drawing a figure through which you'll be able to understand how this system works. This is a typical setup of ultrasonic welding arrangement. Here a load or a force is provided on the tip of the sonotrode, and there is a velocity transfer. This is a velocity transformer, which is basically a transducer over here. The transducer are two types: piezoelectrical crystal and magnetostrictive transducer. So the transducer,
Sir, can you please tell us the labels again?
wait. This is called piezoelectric crystal type. Second one is magnetostrictive transducer. Okay. So what is happening here is we provide high frequency supply from the frequency converter, and we supply to the setup of the ultrasonic welding. This supply again goes to velocity transformer, and at the tip of end of the velocity transformer, the sonotrode is attached. The sonotrode having a load application system which takes load and provide the load to the tip of the sonotrode, and as a result this end vibrates in a very high frequency for a very small quantity of time, for a very small quantity of time, and as a result the joint is produced. Now this is anvil. Over the anvil the job is kept, and now when we provide power here, this tip vibrates, goes ups and down very in a very high frequency. So as a result, in a very small amount of time, this joint get produced. So the frequency to be provided is 20,000 Hz to 60,000 Hz. Basically, it is used to produce a weld, a thin plate to a thicker one. So when we need to attach a thin plate to a thicker one, then this ultrasonic welding is used. Now, when we use it, when we attach aluminium to steel, when we attach aluminium to tungsten, aluminium to molybdenum, nickel to brass, L to steel, tungsten, molybdenum.
Hello, sir.
বলো।
Sir, transducer is a piezoelectric crystal
Magnetostrictive, STRICTIV.
Okay, sir. Thank you.
So aluminium to steel, aluminium to tungsten, aluminium to molybdenum, and nickel to brass. These cases ultrasonic welding is capable. So the advantage is when you have to join two different materials of two different melting point, then you go for this type of ultrasonic welding, because if you look here, the aluminium get melted, pure aluminium get melted about 550 degrees centigrade, 560 degrees centigrade. Aluminium alloys, aluminium melts about 600 degree. Aluminium alloys get melt about 550 degree. So, and compared with it, steel get melt about 1200 degree centigrade. So tungsten is more, melting point of tungsten is more. So we are attaching two materials which have different melting points. So that's, in such cases we use ultrasonic welding. Now for ultrasonic welding, there are two parts. One is the power source. The power source is provide power to the frequency converter. That frequency converter converts the low frequency current into very high frequency current, and then this high frequency current fed to the ultrasonic transducer. The transducer are two type. One is piezoelectric crystal, second one is magnetostrictive transducer. So the task of the transducer is to convert the high frequency current into high frequency vibration with help of a sonotrode. The sonotrode having a load application facility on which you can set a different type of loads, and that load will be transferred to the sonotrode trip while it is vibrating, and as a result, because of the load, this load depends on the thickness of the material and the type of the material. How much load to be provided in here, how much load that will be provided, that can be selected from the material we are going to join and the thickness of the material we are going to join. Crystals, piezoelectric crystals, may be aluminum, ammonium digrosphaten. It is a very difficult name. I will write it down for you. These piezoelectric crystals may be ammonium ammonium digrosphaten. Suraj Kumar,
Yes, sir.
turn off your mic. Next is Rochelle salt, barium titanate, ceramic. Okay, so these are the crystals which are actually piezoelectric crystals that are used in ultrasonic transducer. Now, this transducer coupling system includes the transducer, which include the sonototrip also, and it conduct the vibratory power to the weld zone. Now then there is an anvil. This anvil is used to supporting the object which to be welded. This one. These are used to support the weldment. Now we have a force application device. So there is a force application device. It applies the static load normal to the plane of weld surface. It might be spring actuated, it might be prismatically actuated, and hydraulically actuated. So when we use which type? So we use spring type, spring actuated, for very small machines, prismatically actuated in medium size machines, and hydraulically actuated in large unit. Now there is a timer. Timer is basically used to control the weld, control the weld interval in spot type, ring type, and line welding type, or a translating or rotating mechanism for continuous seam welding. So there are different type of welding also available. Let us discuss. So we knew that the timer,
স্যার ওই পার্টটা লেখা হয়নি স্যার, এই ফোর্স অ্যাপ্লিকেশন ডিভাইসের জায়গাটা স্যার প্লিজ একবার একটু দেখান।
হয়ে গেলে বলবে। Those who have not,
ইয়েস স্যার বলবো স্যার, এক মিনিট।
those who have not yet submitted your assignment in Google Classroom, please do it fast, because I cannot increase the day. The system is up.
Yes, sir. হয়ে গেছে, স্যার।
হ্যাঁ, মাত্র 2-3 জন করেছে দেখলাম। So please complete your assignment. Probably today or tomorrow is the last day. If you have not seen it yet, just finish it by today. You have to just put tick marks, select the right answer. So just do it by today. Those who have not yet completed your assignment, please do it by today. Okay, so these weldings might be producing a spot, because in this diagram, what we have shown here, that there is a spot. So it is a spot type ultrasonic welding. When we use the tip of the sonotrod as a ring type or as a square type, then it will be a square type shape. So if we use two sheets like this and we use sonotrod tip in this way, so there will be a square welding. Whenever we use sheets in this way and we weld here like a line, then it will be a line weld. Now if we use the vibratory mechanism like a seam weld, we have done the resistance welding, we have learned the seam welding. So if we provide this vibrating mechanism to a seam weld type machine, then we will get a continuous seam weld. Now if again instead of this square shape, if we use a ring type electrode tip, not electrode tip, sonotrod tip, then we get a ring type of joint. So to attach a smaller sheet with a bigger sheet, we can just use a ring type sonotrod tip. So you can change the sonotrod tip as per our requirement, and we get the shape we require in welding. So all the closed loop type, that is square type or maybe the circular type, all these joints are called basically the ring type. Now the variables here, the controllable variables in this ultrasonic welding is controllable variable. Controllable variables are: number one, clamping forces, as because the object will be vibrated over an anvil, so we need good amount of clamping force. Then vibratory power. These frequency varies from 20,000 Hz to 60,000 Hz, which is very large, and depending on the load, the vibratory power will be different. So this is a controllable variable. And number three is time. For how much time the sonotrod tip will be working on the welding zone. So these are the three important controllable variable in ultrasonic welding. This is very advantageous because the working principle, the way it works, it is welded, it should be welded, it is free from the oxide film. There is no oxide because the material does not get melt. It is a solid type welding. It is free from any type of coating, free from moisture, and it is possible only due to the vibration generated during the welding process. The object should be properly clamped between the welding tip and the anvil. Anvil is just used to support the workpiece and the tip. The high frequency converter converts the 50 cycle line power into a very high power. Now there is a problem when the vibration occurs. Due to the vibration combined with static clamping force induce the dynamic shear stresses in the workpiece. Then the plastic deformation takes place at the joint interface. Any coating or any other oxide coating are shattered and dispersed so that the intimate contact and the bonding of the workpiece surface takes place. I am trying to make you understand with a diagram. I don't know how much you will going to understand, but let us just discuss. Suppose these are the border of two different materials. Okay, these are the borders of two different materials. Now when the vibrating force and the clamping force occurs and the object vibrates, so after the welding these two different materials, this is a base metal, this is another base metal, and this when get welded, there is a zone produced in which the particles get dispersed one into another, and as a result the joint is being produced. So this is how the joint get produced. So here these two lines to be jointed after providing the vibration. This uh, intersection between these two different base metals, the particles get dispersed one into another, and as a result we get a joint. And this joint is without any oxide film, without any coatings. If there was any oxide film on the surface between them, at the joint surface, they get shattered and they get cleared out. The materials suitable for ultrasonic welding are basically non-ferrous type, and their alloys of any other combinations. So if we talk about application, but there are bounding materials to be used which are non-ferrous, like copper, aluminium, brass. These are very common, and you have to remember that this lead, zinc and tin, these are soft materials, but they cannot be welded because they cannot have the adherence property. These are cannot be welded, and they will lead to only smoothing of the bonding area. These are not going to bound with other. Lead, zinc and tin, these are not going to bound with the other because they don't have these additional properties. These will lead only smoothing of the area. But this copper, aluminium, brass are very common. These are get welded by this ultrasonic welding. This is used in every type of industries, like small motor armature, aluminium, gold and lead wires are wire connections to the transistors of diodes. So I'll write it out: aluminium, gold, lead wire connections with transistors or diodes. Helicopter access doors, dissimilar metal joints in solar connectors, containers of explosive materials are made with ultrasonic welding. Explosive materials that includes nitroglycerin, uh, includes pyrotechnics. These are basically fireworks. Pyrotechnics is fireworks. So there are few containers that are to be used. The advantages are, let us discuss the advantages very quickly. Advantages are low temperature involved, not high temperature is required. Low temperature. The metallurgy of the parent metal does not completely get changed because of the low temperature. So metallurgy does not get changed of the parent metals. Stronger joint is produced. Number 4, welding aluminium to glass is possible. So glass welding is not possible in other manner. So aluminium to glass is possible. I have not seen it. I have just read it in book. There is no need to slag removal. No need of slag removal. It is a faster weld process. Faster weld process with proper penetration. Equipment is reliable and moderate skill operator is required. Equipment is reliable and moderate level skill of operator is required. Thick and thin section are joined. Number 9, minimum surface distortions because there is no such heat. Number 10, dissimilar materials with different melting points. Lot of advantages. Different dissimilar materials with different melting point can be joined, and it has disadvantages too. Disadvantages are that it is mostly restricted to aluminium. Number 2, applicable only up to 3.2 mm, only up to 3.2 mm thick. Number 3, not economically competitive with other processes. Number 4, material get welded with sonotrode tip. That is a big problem. And number 5, fatigue strength is lower of the joint. So these are the problems. And there is no shielding required, no special shielding, no shielding of eyes is required because there is no such hazards. There is no UV lights, there is no infrared, and there is no hedge, namely heat affected zone. So that is also advantages. So with it, we have completed our ultrasonic welding process. Is there any questions?
No, sir.
Okay, then we will stop today. Please complete your assignments. Time is up. Please complete your assignments as early as possible.